Hello, welcome to the video. In this lesson, we're going to be taking a look at section 5.7, where we're going to be using congruent triangles. So, the question that they pose here says, how can you use congruent triangles to make an indirect measure? Or how can you use congruent triangles to prove that certain sides are congruent or even certain angles are congruent. So up to this point, we have looked at I believe it's five different ways that we can prove triangles are congruent. So we could use the side angle side, side, hypotenuse leg, angle, side, angle, and then finally angle, side. So we were we could use any one of those theorems to prove that triangles are congruent. Once you have shown that that two sets of triangles are congruent by using one of those five theorems, then you can make the indirect assumption that whether or not they show you or not, that all corresponding sides will be congruent and all corresponding angles are congruent. Once you've established that two sets of triangles are congruent, we can then make the conclusion that those corresponding sides are congruent and those corresponding angles are congruent. And the use or the statement that you are going to give to show that those particular sides or angles are congruent is using something that's called corresponding parts of congruent triangles are congruent. And in short, we usually write it as CPCTC, okay? Corresponding parts of congruent triangles are congruent, all right? So that's the short version of it. Writing that, when we write a proof, writing CPCTC in the statement shows that, all right, we've already done a proof that those two triangles are congruent. Then we can make a conclusion that either like those corresponding sides are congruent or corresponding angles are congruent. And I'm going to show you through examples how we go about doing that. So to start with, it says they want us to explain how you can use the given information to prove that the hang glider parts are congruent. So right now, what they gave us is that angle 1 is congruent to angle 2. So I'm just going to put little hash marks there to show that. And they also say that angle RTQ, so I'll just go right here, RTQ is congruent to RTS. So I'm just going to write that in. So looking at this as a proof, I got my statement and I got my reasons. Okay, so first thing we always do when we write our proof is we write our givens. So we say that angle 1 is congruent to angle 2. We can also say that angle RTQ is congruent to angle RTS. And that was given to us. Okay, so from here, all we have is with respect to the two triangles, they want you to prove that QT is congruent to ST. But in order to do that, I want to see if triangle RQT and triangle RTS is congruent first, and then I can make a conclusion that those line segments are congruent. So because angle 1 and angle 2 are congruent, I can now make the conclusion that angle, was it RQT is congruent to angle RST. All right. The reason for that is those angles are supplementary angles to congruent angles. If you wanted to write, there's other ways you can write this. You could make it, much more longer out proof and say like, oh, you know, angle 1 and then QRT is supplementary angles, do a definition of supplementary, and then same thing goes there, and then do some kind of transitive property situation. But this kind of shortens it up a bit. So now I can say that those angles and those angles are equal to each other. Now I can say that RT is congruent to RT due to the reflexive property. And so I have all the information to show that triangle, we'll say RQT, is congruent to triangle RST because of angle, side. All right, so I proved that those two triangles are congruent. All right, but that's not the proof that they're looking for. They actually want just to show that, oh, QT is congruent to ST. Well, the reason why I showed that those two triangles are congruent, now every single corresponding side and every single corresponding angle will be congruent because I just showed that those two triangles are congruent. So now QT is going to be congruent with ST because they are corresponding sides. So now the last thing I can say is QT is congruent to ST because finally of corresponding parts of congruent triangles are in fact congruent. All right. You can't just write this in until you establish that two sets of triangles are congruent. All right. So that is how that gets set up. If we look at another one, here they're asking you to explain how we can show that angle A is congruent to angle C. So right off the bat, looking at statements and looking at my reasons, here they have some givens in the diagram. They say that AB is congruent to BC. They also say that AD is congruent to DC. That is given. All right. They don't show it, but BD is going to be congruent to BD due to the reflexive property. And all of the sides are congruent. So I can now say that triangle ABD will be congruent to triangle CBD because of side, side, side congruency. Okay, now that I've showed that all or those two triangles are congruent, now I can say, oh, all the corresponding sides are congruent. So since this is the first, A is the first and C is the first letter that I wrote in my congruency statement, I can now say, oh, A and C are going to be congruent angles. So finally I can say angle A is going to be congruent with angle C because of corresponding parts of congruent triangles are congruent. Here, it says, use the following method to find the distance across a river from point N, so point N is right there, to point P, which is right there. Here it says place a stake at K on the near side. So we're placing this a stake here so that NK is perpendicular. And then they want us to find M, the midpoint of N and K. So midpoint meaning that they're equidistant, so NM is congruent to MK, which it shows on the diagram. And then here it says locate the point L so that NK is perpendicular to KL, and L, T, and M are collinear, which means they are on the same line. Explain how this plan allows you to find the distance. So in order for you to find the distance, you can actually create this as um, attempting to create this as the set of congruent triangles. So we know that angle K and angle N are congruent because they're both right angles, and we know that MK and NM are congruent because of the definition of midpoint. All right, then because they are collinear, I know that this angle here and this angle here is congruent because of vertical angles. So we can make the conclusion that triangle MLK is congruent to triangle MPN because of angle side angle. All right, so because of that statement, now all of the corresponding sides are congruent and all the corresponding angles are congruent. So, all right, so for example, like whatever this angle is, L, and whatever this angle is, P, is going to be congruent because of corresponding parts of congruent triangles are congruent. Well, they want you to figure out the distance. So actually the distance between LK and NP is actually going to be the same distance because of the same reason corresponding parts of congruent triangles are in fact congruent. So to find the distance, all you have to measure is the distance of NP is just going to be congruent to whatever the distance of LK is. So that's how you can find the distance for that. Here's another proof where they're asking us to use the given information. So they're telling you that angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4. They want you to find out if triangle BCE, so this triangle here, is congruent to DCE, which is this triangle here. So it's these two small triangles on the left-hand side of this diagram. All right, so looking at this, so what I'm going to do first is I'm going to try to attempt to do as much as I can to the proof for those two triangles, and then if I can't, I'll have to see if I can figure something out to help us write a better proof or improve the proof, I guess. So right off the bat, they say that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. That is given. All right. All right, part of these two triangles here and here, I know that I can say CE is going to be congruent to CE due to the reflexive property. And right now, for those two triangles, I have an angle and a side. At the moment, I do not have another side and I do not have another angle. You know, some people may think like, oh, you know, this DEC and BEC, they must be 90 degrees. Could they be? Sure, but I can't prove that. So what we're going to do here is I believe that I can prove that this triangle here and this triangle here are congruent. All right, so by doing that first, that I think that'll help us in proving that those two other triangles are congruent. So with that being said, I can now say for step 3, I can say that CA is congruent to CA by the same, it's reflexive. And now I have an angle, a side, and an angle for both for those two sets of triangles. So now I can say for step 4 here in the statements, I can say that triangle CBA is congruent to triangle CDA because of angle, side, angle. Okay? So now that I have that knowledge, or I have that opportunity to say that those triangles are congruent, now why does that help us? Well, now I know that CB and CD are congruent. All right? Why? Well, I know that CB is going to be congruent to CD because of those two triangles on the top and the bottom are congruent, and those are corresponding sides. So I know that corresponding parts of congruent triangles are congruent. That's how I'm able to make that conclusion. Now that I have those two congruent sides, I have a side, an angle, and a side. So now I have enough information to say, oh, now I know that triangle BCE is congruent to triangle DCE because of side, angle, side. So I had to use two congruent triangle theorems to prove this, but I had to use that corresponding parts of congruent triangles are congruent before I could make that last statement. All right, here it talks about not question 2 here. It says an example 2 that talks about the the river and the trees and stuff. It says, does it matter how far point N you place a stake at point K? The answer is no, because they said it was the midpoint. And since it was the midpoint, we knew that those line segments were going to be congruent anyway. So no. Here, question 3 here is they ask you to write a proof for the diagram to our right. They want you to prove that triangle looks like PTU right here is congruent to triangle UQP. So those two triangles. Okay. So what I'm going to do is I'm going to write it out as a formal proof. Now it's a kind of a lengthy proof, so please bear with me. So I'm going to make some room here, and I'm going to kind of bounce back and forth. Um, so I'll try to move this a little bit lower so we can see the diagram as we're writing the proof. Okay. So I got my statements, and I have my reasons. Okay. So first part, looking at the diagram, looks like it says that PR is congruent to SU, and looks like it says that angle PRT and angle, what is it, QSU are right angles. So that is given. All right. So I believe that in order for us to show that the two triangles that they want to prove that are congruent, I believe that we have to look at like these two triangles here are congruent, and we have to look at these two triangles here are congruent. and then we can use corresponding parts to help us. So what I'm going to do first is I'm going to attempt to try to show that like RTU and SQP are congruent. So with that, because this like TRU and QSP, they're a linear pair to a 90-degree angle, I can also make the conclusion that those are also 90 degrees. So with that, my second statement, I'm going to say that angle TRU and angle QSP are right angles because they're linear pairs, so it's going to be definition of linear pair. With that, I'm going to look at looking at this line segment right here. Looking at this line segment right here. Now, with that line segment, I'm going to say that TR plus RU will be equal to PU. You can also say that PS plus SU is going to be equal to PU. All right. The reason why I can make that statement is segment addition. Okay. Now, what I'm going to do now is since they're both equal to the line segment PU, I can say in this fourth statement is that PR plus RU is going to be equal to PS plus SU. And that comes from the transitive property. All right, so now, why is that important? What I'm going to do here is look at this statement here is PR is congruent to SU. So I'm going to use one of the two and substitute in. So I'm just going to like substitute PR out. So for part 5, I'm going to say that SU plus RU is equal to PS plus SU. And I just substituted that in. You could have easily substituted the other way around. It's not a big deal. I spelled that wrong. All right. So now, finally, I can subtract SU to both sides. So now I can say that RU is going to be equal to PS because of subtraction. All right. Now, with that, looking at this triangle here, I know that this is 90 degrees. I know that RU is going to be congruent to PS, and they're both right angles. So now I know that triangle QSP is going to be congruent to triangle TRU because of hypotenuse leg. All right, we knew it's a right triangle. I got two congruent hypotenuses right here and right here. I found out that this segment here is the same as this segment over here. I'm able to use hypotenuse leg to make that proof. All right, now, because of this triangle here and this triangle here are congruent, now corresponding parts of congruent triangles are in fact congruent. So now I can say that TR and QS are congruent because of corresponding parts of congruent triangles are congruent. So I can say, so TR congruent to QS because of corresponding parts of congruent triangles are congruent. Now with that, I have a side, an angle, and a side, angle, side. So now with the two small right triangles on the outside, I can now make a conclusion that triangle is what PRT is congruent to triangle USQ. I'll make sure I have that right. Because of side, angle, side. I'm sorry, this is just a long proof. It just is what it is. So now that I have that these two triangles are congruent, now I can make it the conclusion that these two sides are congruent because of corresponding parts of congruent triangles are congruent. So now, so for part 10 here, I can say that PT is congruent to QU because again, corresponding parts of congruent triangles are congruent. Now, I have most of the information I need. Now I can just say that these two are going to be reflexive. So part 11 here is PU is congruent to PU because of the reflexive property. And now finally, I have all three congruent sides for this triangle here and this triangle here. So now we can finally say, after 12 steps, that triangle PTU is congruent to triangle UQP. I believe that's what it was. Yep. Because of side, side, side. Again, like I said, it's a long proof, but if you break it down, um, it's a bunch of properties and a bunch of statements that we've made before in other proofs. And that is being able to use congruent triangles. Hope this helps. Till next time.